Adapt Floor Pro 2010 offers a comprehensive new feature for the evaluation of vibration caused by footfall or other sources in a conventionally reinforced or post-tension floor system. This tutorial will demonstrate the recommended steps for carrying out a footfall analysis and check for a two-way 8-inch thick conventionally reinforced slab. The tutorial will cover the analysis of the entire slab, an isolated region of the slab, and a revised slab demonstrating the effect on natural frequency by adding mass in the form of thickening the slab region. The 6 steps recommended for evaluating the perception and acceptability of vibration caused by footfall are: determining the natural frequency using an appropriate input in Adapt Floor Pro 2010, determining the excitation force of vibration, determining an appropriate damping factor for the specific floor type, calculating the effective weight of the panel under consideration and any superimposed load, determining the peak acceleration ratio caused by footfall on the floor, and evaluating the acceptability of vibration given the natural frequency and acceleration. In the first step, we will create a model in Adapt Floor Pro 2010 and determine the natural frequency for the first mode of vibration. Once the model is created, we'll go to the FEM Design tab and we'll select Vibration, which will open the Vibration Combinations box. We'll use one load combination, which is vibration 1 times the self-weight, and it has a dynamic participation factor of 1 in the global z direction. And finally, the results will show us the frequency at 6.35 Hz. We'll proceed in Adapt Floor Pro 2010. In Adapt Floor Pro 2010, we have a model created which is an 8-inch thick two-way conventionally reinforced slab. From the FEM tab, we'll select Vibration, and note that the only vibration combination currently written is the self-weight times 1 as the load combination factor. So we can also include an additional combination simply by clicking on the box and inputting an additional combination. For this example, we're only going to use the first combination. Notice also we have a mass participation factor of 1 in the z direction. We'll go ahead and select OK. And the next thing we need to do is to analyze the structure. So we'll go to FEM. We've already meshed the structure. We'll go to Analyze, and the structure will now be analyzed. Once the analysis is complete, we'll select Yes. And to determine the frequency of the floor system, we can go to FEM, View Analysis Results, and the results viewer will appear. At the left-hand side, we're going to select Vibration Results, and under the first load combination, which is Vibration 1, we'll go ahead and expand that, and we select to do input 3 modes so we can review the frequency for the first mode, the second, and also the third. In this particular example, we're only including the first mode for the results, as this will usually provide the lowest frequency for the slab. We'll go ahead and turn on the display using the light bulb icon, and here we can see the vibration or the normalized amplitude of vibration for this specific mode. The frequency here is 6.35 Hz, so this is the value that we're going to use in the analysis continuing. The second step is to determine the excitation force, and for this example we're using footfall as the source of vibration, so we're going to calculate P0 equals the weight of the person times a dynamic load factor. The probable weight of the person we're going to use is 150 pounds, and we're going to assume a number of steps that the person takes is 2 steps per second at a frequency of 2 Hz. So from the chart we can determine a dynamic load factor of around 0.53, which would give us a constant force of P0 equal to 79.5 pounds. This will be used in determining the acceleration ratio later on. The third step is to determine the damping factor beta. So from the table shown on the slide, we're going to select the occupancy and the damping factor. If you're unsure of the factor, use a value of 0.03. For this example, we're assuming that the floor is furnished with low partition walls. This results in a damping factor of 0.03. The fourth step is to calculate the weight of the vibrating floor panel. The panel volume and normal weight density will be used to calculate the effective weight of the floor panel in addition to any superimposed dead load which will follow the path of vibration. In this case, we'll use 20 psf for dead load, and the weight equals 94.5 kips for the 26.25 by 30 foot panel. The fifth step is to determine the peak acceleration given as a ratio of ground acceleration g. We've determined p0, the frequency of the first mode of vibration, which is 6.35 Hz, the damping factor of 0.03, and the panel weight of 94.5 kips. In determining the peak acceleration, we come out with 0.303% g. The final step is to evaluate the slab. Given the natural frequency of 6.35 Hz and the peak acceleration ratio of 0.303, we can refer to the ATC chart to determine the perception and acceptability of vibration for this slab. In this case, we're below the threshold for offices, residences, and assembly halls. However, we're above the threshold for operating rooms or other very sensitive facilities. In this case, we would need to modify the slab in order to meet an acceptable range. The next step will be to isolate the specific panel using the excluder function in Adapt Floor Pro and redoing the design. For this example, we're going to isolate a specific region of the slab for the vibration analysis. This will include the original panel under investigation, panels to the left, the right, and also the top to gain a more accurate representation of the vibration results. First, we need to go to the FEM pull-down menu, and we need to clear the mesh. Next, from the FEM process toolbar, we're going to exclude the meshing. We need to select the region for analysis. So using our snap tools, we can input the region. If we double-click on the boundary, we can see that we have the option to limit the analysis to inside or outside the polygon. We'll select inside the polygon. And next we need to input the boundary conditions or supports for the left and the right hand sides of this slab boundary. Under the Build toolbar, we'll select Support, Line Support, and here we have a rotationally fixed and free to translate in the XYZ support. So we'll input these supports on the left and right side. Once the supports have been input, we can mesh the structure. From the FEM pull-down menu, we'll select the automatic mesh generation, and we can see that the slab has been meshed only inside the region for analysis. We'll go ahead now and analyze the structure. From FEM, go to Analyze Structure and select Yes. Once the analysis is complete, we'll select Yes, and to view results, we'll go to the FEM toolbar, select View Analysis Results, select Vibration Results, and we can expand Vibration Load Combination 1. We'll select Mode 1 first and display the results. We can see that the frequency for this model is 6.74 Hz, which is in good correlation with 6.35 Hz from the original model. We can also rotate the view, show a warped view, and we can animate the view as well using this function. We can toggle between modes to show each animated view. If we review the evaluation phase of the first example, we can see that the threshold for the operating room or other sensitive facility was exceeded. So in the final example, we're going to increase the thickness of the slab to see if we can lower the frequency and meet some acceptable range for an operating room or some other similar facility. Going back to our original model, we're going to select the slab and we're going to increase the thickness from 8 inches to 10 inches. We're going to select FEM, Automatic Mesh Generation once again. and we're going to analyze the slab. So we'll go to FEM, Analyze Structure. We'll now select Yes, and going back to the FEM toolbar, we're going to go back to View Analysis Results. Under Vibration Results, Mode 1, we now have a frequency of 7.72 Hz. In evaluating the revised slab of 10 inches thick, we can see that the frequency is now 7.72 Hz. P0 remains the same at 79.5 pounds, as does the damping ratio of 0.03. The weight of the panel increases to 115.3 kips, and finally the acceleration as a function of g is 0.154%. Reviewing the ATC chart again, we can see now that this value falls below the threshold for operating rooms and other sensitive facilities. The 10-inch thick slab and the increased 10 inches thick has provided a suitable solution and an acceptable design for vibration for this particular model. This will conclude the tutorial for vibration in Adapt Floor Pro 2010. In Adapt Floor Pro 2010, we have an 8-inch conventionally reinforced slab for the vibration analysis. The vibration results will be focused on this bay. First, from the Criteria menu, go to the Analysis and Design Options tab and make sure that Include Vibration Analysis has been selected. Next, we'll go to the FEM tab, Vibration. The default load combination is 1 times the self-weight. To add additional combinations, we can select the box below, write in the combination name, and include components in the lower box. The user has the option to include the number of modes and also the participation factors for the X, Y, and Z directions. In this example, we're only going to use combination 1. From the FEM tab, we now need to mesh the structure. Once the structure has been meshed, we can analyze the structure. Again, from the FEM tab, go to Analyze Structure, select Yes, and the program will begin the analysis. Once the analysis is complete, we can select Yes, and to view results, we'll go back to the FEM tab, select View Analysis Results, and select Vibration Results in the left-hand panel. We'll expand the view for Vibration 1, and we'll select Mode 1 and display the results. In the results viewer, we can see that the program reports the frequency, the period, and also the normalized amplitude. We can also view these results for Mode 2 and for Mode 3. For any of the modes, we can select a warped view, and we can animate the view as well using the animation option. The period of the first mode will be used in the following sections of this example.